Good day, grade 12. In this video, we are going to answer this question given a block of mass 2 kg that is sliding down a plane inclined at an angle of 30 degrees to the horizontal as shown in this diagram. So in actual sense, we have this block. It is sliding. We don't have force applied, however, it is sliding, obviously due to the fact that it's an incline and we have a certain angle here. So now I want to focus on these two kind of questions that has to do with drawing a free body diagram and also calculating the acceleration of the block. That's the question that I want us to focus on. Now, let's check this block out and identify some of the forces that are applicable in the as far as this problem is concerned. We have the frictional force. Why? Because we are told that the kinetic friction between the block and the plane is 0.2, meaning that we have friction force, and it's pointing towards that direction because the sliding part is sliding towards this direction. So let's write it as Fk for friction force. We also have the normal force. The normal force is always perpendicular to the surface. So that's the normal force here. It's written like this. We also have a gravitational force, which can be written as Fg. If we check it out, gravitational force just goes straight like this, right? It didn't go straight, continue from from the normal force line, but you just draw a line going down like this from the center of the object that we are talking about. Now we also have the force that is perpendicular to the surface, and I will call it F perpendicular. So this force is perpendicular to this surface. It entered this surface with a 90 degree. If you can check it out, you will realize that it goes straight like this. Then we have the force that cut it in half like this. So that's the F perpendicular. So it's just a continuation from the line of the normal force like this. We also have another force that is parallel, but before then, let me indicate the angle that we have here. So we also have an angle of 30 degree here. Why? Because this angle that is here, it's always the same as this angle here. If you are not familiar with this concept, I have another video that has to do with this session. Please kindly go and watch it out and learn. So this angle is the same as this angle always, meaning that if now this angle were given to be 25 degree, I was going to write 25 degree, but this time since they told me that it's 30 degree, I will write 30 degree. So whatever angle that we are given in exam or test, whatever incline angle that is given here, it's always going to be the angle that we are going to write here. From there, let me go to F parallel. This is the force that is parallel to the surface. Why? Because can you see this line here going like this? This line going like this. This line is parallel to this line here from this arrow. So I'm saying we have parallel. This line is parallel to this one. That's what you mean when you say parallel or F parallel. From there, and it's always pointing this side, like what this arrow shows, this parallel line. Now, from there, I want us to draw a free body diagram. We will write a dot so that we can identify the forces well. We can write the dot. From writing the dot, we write the friction, the arrow for friction force. From there, we draw the arrow for normal force. From there, we draw the arrow for force of gravity, which is written as Fg. Lastly, I want you to check F parallel. Can you see F parallel is part of the motion because it's going that side, the friction force is going that side. So we must also involve the what? The F parallel, but this time around we'll write it here on top. because it's the same as what is happening here. So we write it like this. Now we'll indicate to say this is F parallel. There was no force applied. If there was force applied or pulling the block towards this direction, we were going to include it also. But this time around, there is no force that is applied. It's just sliding due to F parallel. So the block is sliding down on this side due to this F parallel. Now, I want us to calculate now the acceleration, right? Calculate the acceleration of the block, 2.1.3. We are done with free body diagram. We are going to 2.1.3 whereby it says calculate the acceleration of the block. We know that F net is equal to ma. By the way, this formula is always provided at the back of the question paper. F net being equals to ma. What is F net? We are talking about all the forces that are responsible for the motion of the block. If you check them out, the block is not going up and down because it's just sliding, right, in a diagonal manner like this. This block, when it doesn't go up and down, it simply means that the normal force or the magnitude of the normal force is the same as the magnitude of the F perpendicular. That's why the box is not going up and down. And being able to slide, it simply means that friction force is less than the F parallel that is pulling it towards this direction. If friction force was equal to the F parallel, this F parallel, can you see these two? If this Fk is equal to F parallel, the block was not going to go anywhere. It was going to stand still. However, since the F parallel is higher in terms of the magnitude than the F friction force, that's why it was able to slide. I'm saying this so that we can bring the understanding why are we saying normal force or this force upwards is the same as this force perpendicular downwards here. It is because the box is not going up or down. Instead, it's going to the left like that. Now, the F net, we are referring to the force that are responsible for the movement of this block. Obviously, these are the force that are in the direction of the motion, and the force that are in the direction of the motion are not this one Fg and Fn. No, are these two, which is Fk and F parallel, but they are of the different direction. They are going in different direction. That's why we will write it as what? As F parallel. Let's say we make it positive, but then we are forced to make this one negative because they are going in different direction. We'll say minus Fk because they are going in different direction. Remember, friction force, it opposes the direction of the motion, right? Then I will then say this is equals to ma like this. However, there is a problem now. What is F parallel? It's not given. What is frictional force? It's not given. I don't even have friction force. However, if you check at the back of your question paper, there is a relationship between friction force and normal force, and that's the relationship we are going to use. Friction force is equals to mu k multiplied by normal force, or N. What is this mu k? Is 0,2 we are given. That's the coefficient of kinetic friction. Now, what is N? N is the normal force, or Fn. Some can write it as Fn. It's still one and the same thing. It's the same thing as this Fn that I wrote here. However, if you check normal force is the same as what? F perpendicular. So, as such, we can rewrite this equation. Now we write K. Then instead of writing normal force, we can write F perpendicular. Why do we do that? Because we know that the normal force is equals to the F perpendicular force, because the block is not going up and down. Instead, it's just rolling to the left. It's just sliding to the left like that. Now, the question will be, what is F perpendicular and what is F parallel? I want us to redraw this triangle. Which triangle? This one. I just redraw it here, right? This longest side, which is this one for force of gravity, it's your hypotenuse. That's why I wrote H here. 30 degree is this 30 degree is the same 30 degree that is here because that's the same angle, right? Now, This side underneath is this side that is here, which is F parallel, which is the opposite. That's why I wrote O. This one, F perpendicular, it's written as small letter A for adjacent, meaning that that's the adjacent. So by now you should know that tan it's opposite of adjacent, sine is opposite of hypotenuse, cos is adjacent of hypotenuse. You should know that by now. So if you write sine of theta, let's say sine of theta, let's check sine of theta. Obviously theta is 30 in this case. You can even write it as sine 30, right? It will say what? Opposite. What is opposite? Opposite of hypotenuse, right? And what is opposite? Opposite, if you check it out, is F parallel of hypotenuse. What is hypotenuse? Is this side, which is what? FG. This is the side. Can you see it here? It's FG. However, we know that we can now cross multiple and divide by 1 and say F parallel multiplied by 1 is equal to FG multiplied by sin theta. Then we get F parallel being equal to FG multiplied by sin theta. However, what is FG? FG is the same as mass multiplied by gravitational force, meaning that we can replace FG with mg for mass multiplied by what? Gravitational force. So, ladies and gentlemen, we just found now the relationship between F parallel with this information here to say F parallel is the same as mg sin theta. However, let's now continue and write the one for cos. Cos theta, if you check theta is the same as 30 in this case. You can even write it cos 30. You are more than welcome. What does cos says? It says adjacent of hypotenuse. What is adjacent? Adjacent is what? It's F perpendicular. So we'll write F perpendicular over FG. FG is this hypotenuse. You can even see it from this diagram here. That is FG. So when you do cross multiple, you are going to find F perpendicular being equals to FG cos theta. However, what is FG? FG is the same as mg, which is mass multiplied by gravitational force, cos 30 this time around. So this theta, do not worry about it. It's always 30. You are more than welcome to write it as cos 30 instead of theta. I just want to clarify the fact that why are we writing theta or as we are given 30? There was no need to write it as theta like this. You can just write it as 30. It should be fine like that. Right? From there, if you check it out, this is the equation that we stuck on. This time around, we managed to find F parallel. Where is F parallel? Here it is, mg sin theta. What is mass? We know mass is 2. What is gravity? Is 9,8 sin 30. You can press the calculator. You can substitute and press the calculator, or even pause this video. Then, what is Fk, which is this one for the frictional force? It's mu, or coefficient of kinetic between the block and the plane, which is 0,2 given here, multiplied by F perpendicular. What is F perpendicular? Is mg cos 30. What is mg cos 30? Mass 2, gravitational force 9,8, cos 30. You can pause the video and substitute and find the answer. After substituting, you will realize that we are going to have mg sin 30 minus mu. Then instead of writing F perpendicular, we'll write mg cos 30 like this. Mg cos 30. From there, we will say equals to ma like that. From there, it's just a matter of substituting. We know the mass is 2 we are given. There is 2 here, 2 kg. Gravity we know is 9,8. Sin 30, cos 30, we can press the calculator and find those values. What about this m? It's also going to be 2 because we are given. So that's how we substitute. When you substitute, you can find the answer for here. You subtract. Here we have 0,2 mg cos 30. You substitute. Then you said it's equal to 2a. From there, you press a calculator and solve for a, and you will find the answer for a being somewhere around 3.2.